In this video, we're going to do some algebra problems with inequalities. So instead of an equal sign, we'll have less than or equal to, greater than or equal to, greater than, less than signs. Okay, similar to when we have equalities, we still have the additive property of inequalities. So what that means is plus and minus are opposites. Let's do an example. Here we have an inequality. So similar to when we have equalities, let's put a little dotted line. And whatever we do on one side of the equation, we'll have to do the exact same thing on the other side of the equation in order for the inequality relationship to stay the way it is. So like always, we want the one letter to be all alone, like U. We want it all alone. In order for that to be the case, we need to remove this minus 18. Well, the opposite of plus is minus. So if we want to remove a minus 18, we'll plus 18. Now, if we plus 18 to the other side, it's not going to change the inequality relationship. So we have just U here. Minus 20 plus 18 is minus 2. And this inequality symbol will stay the same. Let's look at one more example. Here, the inequality sign, we put a little dotted line. It says minus 13 plus y is less than minus 7. That means as long as we do the same thing on each side of this green dotted line, then the less than relationship will stay the same. So again, we want y all alone. We want to know what is true about y in this equation. So in order to get it all alone, we need to remove that minus 13. So we will plus 13, and we can do it on both sides to maintain the less than relationship. So minus 13 plus 13 gets removed. We have y, and then you have minus 7 plus 13. That's a positive 6, and the less than relationship will still hold. Okay, now we're going to talk about the multiplicative property of inequality, and this is where it gets a little bit different than regular equalities. But similar to regular equalities, multiplying and dividing are opposite procedures. There's just a little bit extra we have to pay attention to when there's inequalities, and I'll get to it by doing an example. Okay, here's an example. 16 is less than or equal to minus 4w. So again, just like any algebra problem, we want to isolate w. We want to have w all alone. So we're going to have to remove this minus 4. Now the opposite of minus 4 times w would be dividing by minus 4, but if we do it on the right, we must also do it on the left. Okay, so minus 4 divided by minus 4, it leaves you with w all alone. 16 divided by minus 4 is minus 4. Now here's where we have to be really careful. There is a rule when you have inequalities that if you divide or multiply by a negative number, then you have to flip the sign. So in our case here, instead of having less than or equal to, the sign will flip since we divided by a negative number and become minus 4 is greater than or equal to w. Now students often ask me, why? Why do we have to do this? So let me explain it to you in as simple way as I can. Let's think of a number line. Here's 0, here's 1, here's 2. Now let me make an inequality that I think everyone would agree to. 1 is less than 2. You can see it on the number line, and we all know it's true. 1 is less than 2. Now what would happen if we multiplied both of those by a negative number, like negative 1 on both sides? What happens is, imagine here's the 1, here's the 2. What's negative 1 times 1? It's just negative 1. So this number is actually moving way over here to negative 1. Let's use different colors. Okay. And negative 2 times 1, this number is moving way over here to negative 2. Okay, so now look what happened. We took this inequality here, 1 less than 2, but if we multiply both sides by negative 1, those points move all the way over here, and guess what? Negative 2, you can see, is to the left, or less than negative 1. So if you wanted to write it here with negative 1 on the left, you'd say negative 1 is actually bigger than negative 2. So you see what happened. If we multiply both the left and the right side of an inequality by a negative, it reflects it across the 0 and flips the relationship. So now instead of 1 less than 2, we have negative 1 greater than negative 2. Okay, let's do one more example. We have here v divided by minus 5 is greater than 7. So again, just like equalities, we make a dotted line. In the end, we're going to want v all alone here on the left. So to remove this dividing by minus 5, we have to multiply by minus 5. But since we do it on the left, we also must do it on the right. Now that's fine, that canceled. And we're left with v all alone, and we have minus 35 here on the right. But if you remember this instruction, if you divide or multiply by a negative number, we have to flip this inequality sign. So instead of v greater than minus 35, we're going to say v is less than minus 35 in this case. Let's do one more example. So here we have 2x less than or equal to minus 12. Like usually, we make a dotted line. And in the end, we're going to want x all alone here on the left. This is 2 times x, so the opposite of times is divide. Now notice, I'm just dividing by a positive 2. Dividing by a positive 2 should not affect or change the inequality sign at all. Even though the right-hand side is still going to be negative, minus 12 divided by 2 is minus 6. I did not divide or multiply by a negative number. I divided by a positive number. So I can keep this inequality sign the way it is. Okay, so now we'll do a few examples involving two-step linear inequalities. Same rules, just a few more steps. So looking at this first example, we make a dotted line. And we say, okay, I want x all alone on this right-hand side. That's my variable. So I'm going to have to eventually remove the 4 and the 7. We'll remove the 7 first because it's farther away from the x. The opposite of plus 7 is minus 7. But if I do it on the right, I have to also do it on the left. Those will cancel. 4x on the right-hand side, and we get minus 20 on the left-hand side. Now again, we want to get x all alone. So I will say the opposite of 4 times x, we divide by 4. If we do it on the right, we must also do it on the left. Those will cancel. Minus 20 divided by a positive 4 is minus 5. Now we did not divide or multiply by a negative, we divided by a positive. So this inequality here can stay exactly the same in our answer. Okay, last example. Here we make our dotted line. Oh, I like to use green. Make our dotted line down the inequality sign. Whatever we do on the left, we should also do on the right. Again, I noticed my variable is y, so in the end, I want y all alone on the left, which means I'll remove the minus 31 and the minus 5. Minus 31 is farther away, so I will say plus 31 on both sides. And then minus 31 plus 31 gets removed. I have minus 5y on the left, and I have plus 25 on the right. Now again, we want y all alone, so we will divide both sides by minus 5, but this is dividing by a negative. So when we divide by a negative, this inequality sign that says less than is going to have to shift to be greater than. Now minus 5 divide minus 5 is just 1, so there's no need to write a 1. 25 divide minus 5 is minus 5.